Continuing on in section 4.8, we're going to multiply complex numbers. We want to know what is each product. So here I'm going to take 3i and distribute it into both pieces. So 3i times negative 5 is negative 15 times I, just like if it was an x, and 3i times 2i. 3 times 2 is 6, and I times I is I squared. This is the only thing that's different here. I squared, we know, is actually negative 1. So I substitute that in for my I squared, which gives me negative 6 minus 15i. And we always do a real part, then imaginary part, a plus bi. So 6i squared is actually 6 times negative 1, or negative 6, minus 15i. For b here, I have a binomial times a binomial, so I'm going to FOIL. Firsts, outsides, insides, and lasts. Here I get negative 4 minus 8i minus 3i minus 6i squared. And again, we know that I squared equals negative 1. So instead of putting I squared here, I put that negative 1, which gives me a plus 6. So 6 and negative 4 combine to give me 2. I can combine my like terms here and get minus 11i. So 2 minus 11i. Again, I have a binomial times a binomial. So negative 6 times negative 6. Outsides. Insides. And lasts. 36 plus 6i minus 6i minus I squared. But again, we know that I squared is actually negative 1. So minus a negative gives me a plus 1, and 36 gives me 37. My i's cancel each other out. These right here have a special relationship called a conjugate. And we're going to talk about that more when we're dividing here. But same firsts, same a value, opposite b value are conjugates, and we're going to use those sometimes to eliminate imaginary parts. So if we look here, when I multiplied those together, I got just a real part, 37, and that's going to come in handy here in just a little bit. Now, feel free to pause here and give this a try. Two terms times each other, so I'm going to take 7 times 3, 21, and I times I gives me I squared. We know that I squared equals negative 1. So 21 times negative 1 gives me negative 21. Here we have a binomial times a binomial, so we're going to FOIL. 2 times 4 firsts. 2 times 5i outsides. Insides. Lasts. Again, we know that I squared equals negative 1. Which gives me a positive 15 here. So 15 and 8 is 23. I combine my like terms here and get minus 2i. Same idea. Negative 4 times negative 4. Outsides. Insides. Lasts. But I squared equals negative 1. So this gives me a positive 25. I can combine my real parts, and my imaginary parts add to 0. And again, that's because we multiplied these conjugates. Same a's, opposite b's. And it gave me just a real part. Number pairs of the form a plus bi and a minus bi are complex conjugates. The product of complex conjugates is a real number, and we can use complex conjugates to divide complex numbers. So when we divide complex numbers, we're going to multiply our denominator by its conjugate. So here I have 0 plus 3i, so I'm going to multiply by 0 minus 3i. Keep in mind we don't need those zeros here. I just wanted to show you that our a part stays the same, our b parts become opposite. And if I multiply the denominator, I have to multiply the numerator. It's like we're coming up with an equivalent fraction. Okay, if I change my denominator, I have to change my numerator. And it works because we can multiply anything by 1 and get the equivalent expression. And negative 3i divided by negative 3i is just 1. Anything divided by itself is 1. So here, in my denominator, I'm going to have negative 3 times 3 is 9. I times I is I squared. In my numerator, I'm going to distribute this into both pieces. Remember, my numerator is one piece. That fraction bar is a grouping symbol. So I'm going to get negative 27i minus 36i squared. We know that I squared equals negative 1. So I'm going to replace both of those and simplify. So this is going to be negative 27i plus 36 divided by positive 9. Okay, last thing I want to do is rewrite this as like a complex number form. So I'm going to put my real part first, divided by my denominator, then my imaginary part, and reduce. So 36 divided by 9 is 4, 27 divided by 9 is 3i. So I just split this fraction up into two pieces, wrote them both over 9. And then just put them real part first, then imaginary part. Same idea here. We're going to multiply, and again, it's our denominator that we're trying to get to be real. We're trying to rationalize or make this denominator a real number. So we change that to the multiply by its conjugate. A stays the same, B becomes the opposite, so 1 plus 4i. Here, in my denominator, I have a binomial times a binomial, so I'm going to FOIL. Firsts, outsides, insides, lasts. In my numerator, I also have a binomial times a binomial. We have to FOIL here as well. Firsts, outsides, insides, lasts. I'm going to simplify here. I squared equals negative 1. So I'm going to have 1. When I combine those, I get 0, which is perfect, plus 16, so my denominator is a 17. In my numerator, I get negative 12. When I combine that with 2, I get negative 10. My imaginary parts are 11i. So again, I just simplified my numerator, simplified my denominator, and what I get is negative 10 plus 11i divided by 17. And I wrote that as two separate pieces because we want our real part and our imaginary part. And it doesn't matter if you have your I in the numerator with your 11 or like this, they both mean the same thing. Okay, so it doesn't matter which way you put them. But this is what we get when we divide complex numbers. We're looking for just a real part and an imaginary part to get it to be one complex number instead of a complex number divided by a complex number. So again, when we divide, we're going to change our denominator by multiplying by its conjugate. So my A stays the same, my B becomes the opposite. I change from plus 4 to minus 4. And whenever I change the bottom, I change the top by the same. Keep in mind, our fraction bars are grouping symbols. So here we need parentheses around each of these. Fraction bars are grouping symbols. So I'm going to FOIL in my numerator. Firsts, outsides, insides, lasts, and the same in my denominator. Firsts, outsides, insides, lasts. When you do this, guys, every single time we should have a negative number here that when I change to be I squared will be positive. You should always add those values together in our denominator. In our numerator, I squared is negative 1. So I'm going to have 15 minus 8 when I combine my real parts, which gives me 7. When I combine my imaginary parts, I get negative 26i. And these are both over 25. And then reduce if we can. Here we cannot. So again, in my numerator, I had real that I combined 15 minus 8 because positive 8i squared is 8 times negative 1, gives me the negative 8. And my real parts, negative 20 minus 6 is negative 26. Same signs, add them up, give the common sign, I. All over in my denominator, my imaginary parts added to 0. So 16 plus 9. Try B. Again, I'm going to multiply by its conjugate. Here, this is 0 plus 6i, so I'm going to multiply by negative 6i. Whatever I change the bottom by, I change the top by. Again, we don't need that 0 there. You can if you want to, though. We just make sure our b is opposite. Again, our fraction bar means grouping symbol, so here I'm going to distribute. 4 times negative 6i is negative 24i. And negative times a negative gives me a positive 6i squared. In my denominator, I get negative 36i squared. We know I squared equals negative 1. So I can simplify a little bit here. This is going to give me negative 6. So I put my real part first, then my imaginary in my numerator. In my denominator, I have a positive 36. And then I always want to reduce if I can. So 6 over 36 gives me negative 1/6. Minus here I can take a 12 out of each of those. So I get negative 2i over 3. Same idea here. When we divide, we're trying to make our denominator a real number. So I multiply by its complex conjugate. Same A, opposite B's. And if I change my denominator, I've got to change my numerator by the same thing. Because really we're just multiplying by 1 here. Anything divided by itself is 1. Fraction bars tell me I have grouping symbols. I'm going to FOIL firsts, outsides, insides, lasts, over firsts, outsides, insides, lasts. Keep in mind we still have grouping symbols here, so we have to completely simplify our numerator and simplify our denominator before we can reduce between them. So here I have a negative 49. So 64 minus 49 is going to give me 15. And when I combine my imaginary parts, I get negative 112i. In my denominator here, I get a positive 49. So when I add 49 and 64, I get 113. So 15 over 113 minus 112 over 113i. So again, we use our complex conjugate here. Keep our a's, opposite b's. Okay, but however we change the denominator, we also change the numerator the same. Multiply by the same thing there, because ultimately we're just multiplying by 1. 8 minus 7i divided by 8 minus 7i is just 1. We FOIL through, simplify our numerator by combining our like terms after we got rid of our I squared to be negative 1. Combine our imaginary parts. Same thing in our denominator. Our imaginary parts added to 0. So I had 64 plus 49 here. I had minus times a negative. And those combined to give me the 113. And we will finish this section in another video.